Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. I talk all about different data science topics and techniques and machine learning, artificial intelligence, and things such as this. So in today's project, I want to look at customer-centric strategy, okay? And we're going to create a couple of models and try to understand how a business can improve its strategy. So I have about 7 videos related to strategy. This is a new series I just started, and I want to share these ideas with you. So first of all, we're going to simulate customer data and do grouping by and recommendations for different types of customers. We can do things like analyze realistic data, segmenting customers by clustering. We're going to do some clustering exercises. That's pretty cool. You're going to see that in just a minute. And we're going to look at different types of modeling techniques to personalize strategies for each segment. So the segment is a cluster. We're going to do some clustering and try to identify these customers, right, that fit into these different buckets, and then figure out how we can meet these customers' needs better and match our strategy with the demand, okay? So we can run a mid-sized business. This can be a retail type of business. Just imagine it's Gap. It could be a grocery store. It doesn't matter, right? Like, how are we going to identify with our customers, deliver high value, and understand price sensitivities and meet the needs and the demands of our customer base, and interact with our customers better and prevent potential churners. So a churn is somebody that's leaving the business. It's leaving your retail outlet for whatever reason. They're not interested in engaging with you or giving you the money anymore, but you want to continue the business, right? So you want to prevent churn or turnover or customers moving from you to a competitor, right? So I'm going to create a synthetic data set right here. Control Enter to run this. We have customer ID. Okay, we have age, income, spending score, purchase frequency. This is how many times they have engaged with your business or spent money at your business. Number of years that they've done business with you, last purchase date, and customer status. Is this a churn risk? Yes or no? And is this an active customer that's happy and they're coming back over and over again? That's what you want. Persistence and sustainability, right? So let me hit Control Enter to refresh this, and I'm going to create an elbow curve. This is called an elbow curve. You can see where the curve bends right here. The optimal point of the bend is number 5 right here. So we're going to create clusters based on, we're going to create 5 different clusters to understand how our customers are being segmented and being grouped or bucketed into these different bins. Okay, so I have the 5 here. This says optimal customers is number 5, and I'm putting 5 down here. So number of clusters equals 5. That's where we get the 5 from above. So the elbow curve again is like your elbow. I'm trying to show you my elbow here. This is the bend and the curve, and the bend is the optimal number that you want to create for your customers, right? So for k-means, you have to tell it how many clusters to create. In other clustering algorithms, we'll see in just a minute, like dbScan or a density-based scan, it actually creates the number of clusters for you, and it creates the ideal number of clusters. But for k-means, you have to tell it how many customers, how many customers you want for your customers. It's kind of a tongue twister. How many clusters you want to divide into your customers, right? So we have the features here: annual income, spending frequency, and tenure, right? And based on this data frame, this could be anything, right? You determine how you want to segment this or how you want to do the clustering, right? So I have other videos that go more into depth, more into detail on clustering, right? You define what the clusters are going to consist of, and all this is based on mathematical representations or distance matrices. I have another video on that. You can see that on my channel to understand how all these clusters are calculated. It's based on the distance between 2 points, right? So you do a subtraction from point A to point B, or from B to C and C to D, right? See what the distance is, and everything that is closer together gets clustered together. Everything that's disparate or more spread apart goes into a different cluster, right? So the homogeneous, most likely, most similar types of data points get aggregated together. And if you're heterogeneous and you're different, you go into a different cluster, and all those clusters are homogeneous, right? So you have heterogeneous 5 different heterogeneous clusters, and it's all based on homogeneity, whatever it's called. Like if you're homogeneous, you're similar. If you're heterogeneous, you're different. Okay. So here we have the X clusters and the Y, and we can see what the result is right here. Okay. So based on that, we can create a segment. This is called data frame segment. We're appending a new column onto the original data frame, right? Based on k-means, this is X scaled. You always want to scale this data, right? Because you can have outliers, you can have things that are very disparate and very different or very similar, right? And those are the same types, but you have to scale everything together. So it's kind of relatively similar so you can create your clusters, right? So that's how we create the k-means cluster, and we can go ahead and do the plot right here, Control Enter to refresh. Here's my plot. I want to change this just a little bit, comma, width equals, I like this one, height equals 500. I like that. Okay, Control Enter. Yeah, it's a little bit better. Just a tad better. And let me change this one to Control Enter. Okay, we'll see the 3D cluster in just a moment. So let me take you through this. So we have the first cluster here. So we have the clusters assigned, right? This is the k-means clustering. We're assigning a new column right here in the data frame. So this is cluster 1, this is 3, this is 2, so on and so forth. So we're just plotting it. I like these plotly charts a lot. You can zoom in, you can zoom out, you can do whatever you want, right? You can see all the details. So we have 5 clusters. It goes from 0 to 4, Python 0 based, and it goes up to 4. So 0, 1, 2, 3, 4, those are the 5 clusters that you get. And you have the layout here, but I'm not super happy about this clustering arrangement because you see a lot of overlap. You see things mixed together, they're blended. It's not like really good clustering, I don't think, right? So I'm going to take a quick look at this 3D view down here, and then I'm going to try a different approach to this clustering. So in here you can see it is kind of getting the oranges together, the yellows together. Again, we have 0 through 4. Those are the 5 clusters. The darker ones are 0, right? This is segment 0. And between here, you have segment 2. Over here is orange, so this is 3. And yellow is what? Yellow is 4. Okay. So you can zoom in and zoom out. You can see the different representations here. And that's kind of cool. And I think it's kind of working in a 3-dimensional space. But in a 2-dimensional space, it really doesn't work. Like I can't really see the different clusters down here. So I'm going to try a different approach. This is called DB scan. This is for density-based scanning, and we're looking at different clusters based on the density of the calculations of how far or how close something is to something else, right? That's how we create our clustering. I want to put in a little bit different chart down here. Okay, so based on DB scan, we're getting now up to 10 clusters, or I guess 11 because it starts at 0. So 0 to 10. I see a 10 over here. I see a couple reds. So the reds are the 10s. If I go over here, this is 9. This is actually a 9. I thought that was a 10. Sorry, that's a 9. So anyways, we go over here, and still things are kind of like packed in. I can't really differentiate which, like how to develop my strategy or how to develop my marketing to different customers based on the needs of the customer. And again, we're looking at these features right over here. Okay, so we're looking at annual income spending score, purchase frequency, and 10-year years. Like how do I, based on these features, how do I identify my customers better and reach their needs and satisfy their needs better and help them to make more intelligent purchases at my store and help my retail business? How can I help my customers help me? How can I help you help me? So let me create a different type of chart over here. Okay, and that, what is that saying? Value of color is not a column. Let me refresh this thing. Okay, should be in a column because I just did this before. Okay, now it's in there. Okay, you have to do these things in order, right? Otherwise you get these weird errors popping up. So this is a different type of clustering. This is called agglomerative clustering. So we're taking everything that we saw in the first k-means clustering. We're segmenting all the customers together. DB scan is density-based clustering. And this agglomerative clustering is trying to bring everything together comprehensively, and we're trying to understand the clusters. And again, so in this example, we don't define the exact actual number of clusters. Like with DB scan, it tells us what the number of clusters can be, right? There's no predefined number of clusters, and k-means you have to define the number of clusters, right? Like here we have clusters equals 5, number of clusters equals 5. Down here, dbScan, we don't have that, right? It's telling us there's actually 11 different clusters. The top one is 10. The bottom one is actually -1. So that is defining the number of clusters automatically. And agglomerative clustering is kind of similar. So that's telling us how many clusters we need to create here, okay? And I think they came up with, it looks like 5. We start with 0, we go up to 4. So 0 to 4 is 5. And we can see the plots over here. But again, like everything is kind of like jammed together. I don't really like the way that this algorithm is performing either. Like I'm kind of a little bit frustrated with the k-means, a little bit frustrated with the dbScan. The agglomerative is coming up short as well. Like we're not getting really good results. I want to separate and really define my customer base, who's coming to my retail outlet based on these features, the number of years that you have been a customer, purchase frequency, spending score, and annual income. Based on that, I want to define my customer base and how can I satisfy their needs the best. That's what I'm trying to get to, right? That's what I'm trying to do right here. Let me see if I can put in, a little bit of enhancement here. I want to look at this clustering. So now we're getting a little bit better. And we're looking at PCA. This is principal component analysis. I have a couple of videos on my channel about this. So now we're getting a little bit better type of clustering right here. So down here we have cluster number 4. These are all the yellow dots right here. So this looks pretty good. We have a little bit of an overlap between the purple and the orange, but that's okay. That's okay. I can live with it. I can deal with that. And we have a little bit PCA principal component analysis over here. And this is kind of like a burgundy kind of red kind of color. So we have a little bit of blending with the yellow. Not too much. That's okay, I guess. The purple and the orange are kind of like mixed together. I'm not super happy about that, but the reds and the crimson over here is okay. So I'm kind of okay with that. I can live with that. So let me put in a little bit more definition over here just to get this thing going and straighten this thing out. I want to straighten this guy out as well. Okay, that looks a little bit better. It's easier to read, I think. Control Enter to refresh the cell. So now we have Gaussian mixture modeling, right? So this is another type of clustering. So I'm sorry, there's a lot of clustering here. The video is really about strategy, right? But to understand the strategy or to apply the strategy and to engage the strategy, we have to understand how to reach our customers, and we have to segment them or bin them or cluster them together, right? So we can understand how to engage with these customers better based on the features that we have defined, right? So Gaussian mixture modeling is another way to add another feature to the data frame and to try to understand our customers better. And if I take a quick look right now, I can insert a new cell and go to data. I'm going to copy. I'm kind of lazy. I don't like to type things. Data display. I have to type some things once in a while. Okay, and that is that, but I have a little thing over here. Okay, so now we have the original k-means. This is segment, dbScan, agglomerative clustering, PCA1, PCA2. This is principal component analysis 1 and principal component analysis number 2, and the GMM cluster, right? So we always take these and append that to the data frame. So we have our labels, we have our clustering, we're doing an append to the original data frame and doing a plot based on that. Now we can look at all clusters together. So we have the original k-means, agglomerative, dbScan, GMM, Gaussian mixture model, and then evaluate each model. And we can see based on how these models are performing or how these clustering groups are performing, we can actually quantify how well each one is working. We have a couple different ways of doing that. So this is the original model right here, right? K-means, agglomerative, GMM, and DB. And we have the silhouette method, Katsky, Harbees, right? Davies, Bowden, inertia, silhouette rank, Katsky rank, Davies rank, and the overall score of each of these clustering techniques. So we can try to understand how each one is performing, again, based on the original definition that we set as annual income, spending score, purchase frequency, and tenure in years. So now we can actually rank order each model or each clustering algorithm. And then we can segment those as well. So let me refresh that. Control Enter to run it. So we have the original customer ID, income, spending, purchase, tenure, so on and so forth. And we have the K-means, DB, algo, 1, 2, GMM. And then we have the ranking and the clustering, quantifiable variables over here, right? So that's how we get the recommended score. We break it into segment 0, loyalty, rewards, and discount and programs, and win back campaign. And if none of those 3 criteria are met, then everything else goes into another bucket called high touch customer service, right? So that's a different technique. We have loyal customers, discount and promotions, win back campaign, right? Where there's probably some type of not discount or promotion, because we already did that, but maybe like a more of a what would it be? More of marketing, more advertising to these types of customers. And then the high touch, right? Like we reach out and say, thank you for your business. Give them like a birthday card, send a birthday card in the mail or whatever. Like we want you back. We want to see you back in the store, right? That's the strategy that we're trying to apply. So Control Enter to run this, and we have by segment and by recommended strategy, we're aggregating everything together based on the count, the mean, which is the average, okay, in statistics. It's not really called the average, it's called the mean. We have the annual income spending score and purchase frequency. And based on all of these, we can come up with different customer counts and the strategy recommendations. So we have the loyalty rewards, we have the discount and promotion, win back campaign, and a high touch customer service based on segment, based on the clustering that we did before. So the takeaway from all of this is we use Python to simulate realistic customer data and implement a customer-centric strategy using the pipeline, the modeling pipeline that we created. Like I didn't find the data that I wanted online, so I created it dynamically, right? So you should have the data. If you work in marketing or advertising or whatever business you're in, if you are in either advertising or marketing, it doesn't matter. You have this data. You have this, right? I don't have this data. I don't have your data. Hopefully I don't have your data, because that is very valuable to you, and you don't want that to be leaked outside of your enterprise, right? I don't have your data, so I just created fictitious but realistic data. So based on this synthetic data, approach, we can understand customers' annual income, spending score, purchase frequency, tenure, and what kind of impact are they going to have in terms of spending at your store? How much money are they going to spend? How much engagement are they going to give you? How much business are they coming back with? And are they repeat customers or like a one and done kind of deal, right? That's what you have to understand. So you dump in your data to these models and you can comprehend how to reach these customers. So the final results are ranked to determine the most appropriate algorithm for customer segmentation. And this approach allows you to build your business, to optimize your business, and to do better marketing or advertising. Doesn't matter what you're doing, right? Like those two are pretty similar, slightly different, but mostly the same. And improve customer retention and personalize the outreach at scale so you can engage with your customers and keep them coming back for more and more and more repeat business. You want something that's persistent and consistent. That's the name of the game, persistent, consistent. If you can achieve that, then you have done a good job, my friend. Well done. Thank you. Congratulations to you. Okay, so that is it. I am going to download this code, share the HTML file with you guys so you can run that and do your own analysis on your own data. You have to change the inputs. The outputs are going to be dependent on whatever your inputs are, right? Whatever your business is. I don't have your data. I have my own data. That's it. I'm going to share the code with you when I share the video later today. Thank you for your time. I appreciate it. And I will see you in the next one. Bye.